Hi and welcome. This time around we have another interesting project. This is a hold down fixture for a seam welder. And I know I've shown you there are other seam welders that are an all-in-one unit, but those guys have a round mandrel that's about that big around. And for things like these battery boxes, where you want to weld this seam, it won't work because the diameter is too large to fit in there. So they made this fixture and they need me to update this. This supports other different sizes of battery boxes. This is loose because I've already pre-loosened it here. I've got the screws partially out because I'm making a replacement. But basically this piece goes in here and I can't get it in any farther than that, which is part of the problem. And then these things clamp down on the piece and hold it in place pneumatically. So they pull down and hold it right in place. And that is so what I need to do is replace this piece here. So to get this guy off, this has 4 pneumatic hoses that go to foot actuated pedals where you can clamp down one side and then the other. When you get one side lined up, then you get the other side. I think they put a shim in the middle to get the spacing right. To get the hoses off, I just took a 1/4-inch wrench here and just pushed on the hose until I could get this part in. These quick release connectors are only sort of quick release. Just popping these 2 1/4-20s out. Here's the piece I need to remake, and you can see why this is going to be a problem because it runs in. I asked them if they want me to modify this by like just cutting out a section, but they said no. They'd rather have a separate piece that they could just use for this part. I think it might have been better actually just to cut out a section of this so that you could do this and or the bigger ones on here. They don't care that this is much narrower than this. Which I thought was unusual. I was going to make it to size more or less, but they don't want size. They want it really sloppy. They want me to use 1-inch material roughly like this. And this is like 1 1/4. So it's like a BB in a boxcar. Apparently they just line it manually and run the bead. If you're wondering what these tabs are at each end here, the tabs are so that you can start the laser welding off the permanent weld and end off the permanent weld so you get good weld for the whole length of the part you need. And that's really common with these laser seam welding setups. And then there's gonna be another fixture I'm gonna make in the future where they put the lids on. This is the bottom lid and the top lid or vice versa. And they get inset and then welded around the edge. So let's just get started on this guy. I've got some aluminum over there to cut to make this guy. I bought some copper. Copper they use because a weld spatter doesn't stick to it too much, and it's a great heat conductor. That combination is excellent. They've got a fitting here on this one for gas, argon for backfeed gas, which we will put in. They just took the easy route and drilled a hole all the way through. I'm just going to go to the middle with a small hole down. Got another quick release fitting from a master car. Bought some copper in 2 thicknesses. I bought 1/4 and 1/2 inch. Those are the 2 common thicknesses they've got. I think I'm going to stick with the 1/8 inch. I'm sorry, 1/4 and 1/8 inch. I'm going to stick with the 1/8 inch. I think it'll be adequate. Anyways, let's just get started. A lot to do. First up, we're just going to saw off a piece. I happen to have this piece of scrap, this cutoff from Industrial Metal Supply where I get my material. It's a little over 1 inch thick. I think it's like 1.025 inches thick, tooling plate. And it's not perfectly square, but close enough. And the thickness here, with just a slight modification to the design, can easily take it. And this thickness ultimately doesn't matter. It could be 4, could be 4 1/4. Any of those things would be fine. So let's just saw off a piece here. I'm going to skip showing you all the squaring up of the stock and then I'll bring it back. Just to protect myself, I wrote which side's the top, which side's the mount side. So I'm going to try and drill the hole that goes to the center here for the argon feed. And then I am going to drill the 2 mount holes, drill and tap the 2 mount holes 1/4-20 for mounting this guy. Then we're going to work on this top section. Then finally I'm going to cut out a bunch of material and just clean that up a little bit for the relief so that the battery box can fit. I think we should be pretty good to go on this part. I'm using my electronic center finder. This is one of my favorite tools. Got to be really careful though because they tend to bend very easily, so you got to be very gentle with them. And if they bend, then you find out that they get run out, which means one side will be bent that way, so it'll be closer to this part, but when you go to the other side, it'll be farther away. So you got to be really careful. I love how accurate they are. I can easily get a couple tenths repeatability without any trouble at all. So in this end, I've got to drill a hole that goes halfway, because that's where my argon feed, it feeds from the middle and then pushes the air out both sides. If you had lots of holes, then you can end up with air pockets, which you don't want. So you really want to feed from one part, and since both sides are open, the middle's the best. So far, this is just the clearance hole. This is an aluminum drilling bit that, or a deep bit, that does a fantastic job of clearing chips. And we're there. And you're probably wondering how I got such a long drill bit in the Bridgeport with, I'm almost at the very bottom. And the way I cheat is I put it straight in a collet, because there's just no way you put a drill chuck down here. I don't have enough room without adding a foot riser on the Bridgeport, which I don't have. So this is the solution I choose, and it works reasonably well. Here's the tap drill size. That was a letter R drill bit. Pretty close to the 8-point-something millimeter I used for the through hole. This is 1/8 inch NPT, and as you can see, I just barely had enough room to fit my tapping head. I used this center with the tap this hole here. The 1/4 inch hose fitting I chose to use seals with a gasket as well. So I need to put a seat here. I think I'll countersink this. That actually looks like countersink. I thought this was a flat gasket, but it's actually countersunk. So we'll countersink this guy so that this guy can mate in there properly. Right now it should be able to start no problem, which it does. So a little countersink, and I think we'll be good to go. I chose this style of countersink to hopefully make a smoother land for the fitting. And if you're wondering how you tighten this fitting up, this is a really cool design. They have them with the hex on the outside to tighten it, but if you got a tight spot to get this in, this has an Allen key right down the center. Just feed an Allen key in there and tighten it down. I think this should work pretty well. Okay, we're going to drill and tap the 2 1/4 holes. And that time you saw me make a mistake. Normally, as the tap is retracting, you put a little pressure on the handle so that it doesn't tear the last thread out. Normally I put a little downward pressure so that doesn't happen. I didn't do it that time, which is not good, although fortunately it doesn't look like it did any damage, but you can. All right, so now we're going to flip it over and do the top. We got to relieve this whole section for 2 copper strips that'll be screwed down. And the gap between the copper strips is where the argon will flow. On top of that, we need to drill a hole to meet up with this hole dead center. I don't know if you can see this, I scribed on the bottom. When I'm all done doing this top section, then we're going to cut out all of this section right here. And that will let the part slide all the way in. Copying the old design, we're going to leave a little lip that's 1/10 of an inch wide sticking up over here. I just realized that repositioning this guy up higher is going to cause me problems because there's a hole in the other plate that this needs to go through, and even though my fitting's smaller, it might not line up with that hole anymore. That was kind of a bad move. I didn't want to have to drill with a really small drill bit too deeply through the center. I left only 1/8 of an inch of material, and that was my plan. This would have made that more difficult, although I could have just step drilled it or something. Anyways, now I gotta see if I can make this work, or I might have hosed myself. I gotta take off 0.225 of an inch worth of material here. So we're gonna work our way down, and that's not a critical distance either. But I think we're gonna start with 50 thousandths passes, see how that works. By the way, when using these, inexpensive face mills with the inexpensive inserts, there is no guarantee that the tips are all going to be at the same height. As a matter of fact, there's good chance that they won't be. These tips vary by as much as 2.5 thousandths as far as which one hits. So only one of them is hitting bottom and the other ones are just close. Next up, we got to drill and tap a bunch of 440 holes. 250 thousandths off center. They're going to be 5 a side, so 10 total. We're going to tap them manually because they're 440s and delicate, and I'm afraid to try and power tap those. Now we're going to drill a 0.8 millimeter hole. Wow, that was easy. That was no problem at all. Okay, I got to deburr this side here. This was a PCB drill, as they call them. They're solid carbide. They have an 1/8 inch shank. They have this plastic bit that indicates size via color quite often, although this one, sometimes they print on there. This one does not have it, but pretty handy. I think that's it, except I need to cut out that bottom section on this part. And I'm going to bandsaw a good chunk of it, and then we'll come back and just clean it up. Then this piece should be done. Then I've got to do the copper strips. And the copper strip should line up 50 thousandths either side of that center hole, leaving a 50 thousandths wide strip down the middle. So we're just going to clean up the area that I cut out. I could actually leave it like this, but it just doesn't seem right to do, so we're going to clean it up. Not bad. Just got to deburr this guy. You got to manually tap these spots. I verified that this tiny little hole here in the middle is all the way going through to this, and I put my air compressor up here and nice jet of air blows out here, so I think we're good for this piece. Now I just need to drill and tap or rather drill the copper after I tap this and deburr this. Cutting a couple bars to length, copper bars to length. These are going to fit on top. Using a 1/4 inch parallel, so I had to add a little shim at the end so I could actually have the vise press, because these are supposed to be an 1/8 inch thick, but they're apparently just a tiny bit under. With large calipers, it's hard to know that you're not doing this, so you can search for minimum, but one of the things I do is I extend a parallel out so that I know that the calipers are sitting across the part in a parallel fashion. Looks like we're right there, 7.050. This should be a 5 thousandths pass. Should put me at 0.495, but I'm going to measure and then reset my DRO. For this next part, I'm going to be machining these guys with the edge I just cut up against the fixed jaw, and I'm using 32nd parallels, so I've got springs in there to keep the parallels against the faces of the jaws, because they want to move, and if they move, I'm in trouble. Learned that from Joe Piezinski. Definitely go check out his channel. Even though these two pieces of copper were cut from the exact same bar, the thickness variation means that this top one, it's clamping on the bottom but not on the top. So I've got this can twist clamp here. We're not going to be doing any heavy machining, just drilling through holes and then ultimately countersinking. The can twist clamp will hold them together for the drilling operation, and then I can countersink after. Always try and perform a sanity check, verifying my 0 point. So we want to be in 0.25. We want to go right along what's not actually the center line, but 250 thousandths in. First hole will be at 550. And I will drill 2 holes at a time by stacking them like this. These parts aren't symmetrical, so I drew some triangles on them to know which way they go. Next up, we got a countersink for these Torx 632s, so they sit just below the surface. I screwed up originally I wanted to use 440, and they would have been a much better choice, but I picked the wrong tap drill size out of the drill chart for 440 and accidentally got 632. Measure twice, cut once, I blew it. So we need to set a depth, and then we can just make them all the same. We took the plate off of that fixture. This is where the air hose assembly used to mount, but it's up higher now. So what I'm just going to do is I'm going to make this a slot because that won't hurt anything. It's a big bite. Okay, that should be good enough. That's a 5/8 slot. This hole apparently is bigger than 5/8. I just guessed, but I think that'll be plenty. All right, so I took the faceplate off this guy, which is right here, and I figure it'll probably be easier to mount this before I put the faceplate in because it's kind of a pain to get this in after, and it's pretty easy to put it in now. I'm hoping that guess will be right. If you're wondering, here is the old one. And here is the new one. And this guy goes in here. There are 4 mounting screws on this side and 2 on the bottom. So I will just get these started. There is a bit of slop there. Get the 2 on the bottom started. They use fine threads for the ones on the bottom, 3/8 24, I believe. Pretty weird choice. All right. This is right in line with the other one. Boy, there is only a little bit of slop for that to fit in there. I guess that's the idea. They are going to make new versions of these guys. They're going to use their laser cutter to cut these out, and then maybe I'll machine a bevel on them for them. So you see how I slide the battery thing in. Pneumatically, these guys are popped all the way up. They get one side in first, and in order to line that side, I believe they put a shim down the middle. They said 25 thousandths, and then they just push up against it, clamp the one side down, push the other side in, and clamp down. I believe like something like that. And then they just run their weld bead. I thought you might want to see this in action, so I had to make an adapter real quick between the 1/4-inch hose with 1/8 NPT to 1/4-inch NPT. If I'd realized beforehand that 1/4-inch NPT is what all compressor fittings are, I would have started there, but I didn't, so we'll make it work. Just gonna stick this in between here to line this up. So I'm guessing, oh, wrong side, huh? There you go. So that clamps down the one side. There we go. Puts this in. Oops. Got to get my sides right because they're actually backwards from what I'd expect. All right. There we go. Now the part's held in place. Weld away. And good to go. Those things are really down there. That's only 40 PSI too, but basically that's it. And when there's air pressure in it, you don't have to lift these up manually like you saw me do before. You just put your spacer in there, slide it in. I got to remember this is opposite side here. Pull out your spacer, go for the weld, and that's it. All right, thanks for watching. Hope you find it useful. Hope to see you next time.